Ladies and gentlemen, thank you for being here. Blake, you got your notes ready to go there? All right. Thank you. So today we are talking about proportions again. Yesterday we learned how to solve proportions, and a proportion was something like 4 over 7 equals x over 13. A proportion said that we have a fraction equal to a fraction. How did we solve those yesterday? What did we do to solve those? Cross multiply. Very good. So we did the whole cross multiply thing where we took 7 and multiplied it by x, and that was going to be equal to 4 times 13. And we could solve from there. So cross multiply. And it turned out the first was really, really easy, right? Solving, like yesterday's homework, was really easy in the beginning. A little harder at the second half, but totally doable. Today, we've got more like this, the easy kind. The difference is they're application form. All right, they are real life sort of questions that we answer all the time. So we are doing the same thing as yesterday in terms of solving by cross multiply, but we have to set it up first. And this is where proportions are really handy. It does turn out that we actually use proportions a lot as adults to figure things out when we need to. So proportion word problems. Proportions can be used to solve word problems in which there is a constant rate. It's very important to stay consistent when setting up your proportion. And this is kind of the interesting thing, just being consistent. The units must match on each side of the equal sign. And so looking here, we have sort of basic setup here. Which of the following equations would be a valid setup? Which one do you think is the one we would want to use? The left or the right? Which one seems consistent to you? The right one, yeah. You'll notice that we've got miles in the numerators and we've got hours in the denominators. This doesn't work. They're all switched around. It's crazy. It's not organized, okay? So this is the kind that we want to use where it's nice and organized. And it turns out there's like 7 different ways you can do it correctly and one way that's wrong when you set up a proportion. It's kind of interesting, okay? Now really there's like 4 ways you can do it right and 1 way you can do it wrong, okay? But if you're nice and organized with your units, that's going to work pretty much every time, okay? So keep it organized is really the key. And so we want to make sure that our units stay consistent. So I'm just going to keep the units on when I set it up. And that way I know I'm setting it up correctly. So that's where units can be really, really, really helpful. So directions. Solve each word problem using a proportion. And we're going to round to the nearest tenth or cent when necessary. So why would we use cents? When would it be appropriate to use cents? When we're talking about money, yeah, we want to think about dollars and pennies. So when we're involving money, we'll round to the nearest cent, like money should be $1.87 or $12.39, something like that. Okay, something that makes sense. Sense. Otherwise, we'll round to the tenth place. Okay. So number 1, Pete drove 224 miles in 4 hours on Saturday. If he drives at the same rate on Sunday, how long would it take him to drive 490 miles? Now, I've done a little bit of color coding here. I'm using maroon and teal. And what I'm going to do is I'm going to set this up. First, they're giving me a nice little rate here. In miles, 224 miles. He drove 224 miles in 4 hours. He drove 224 miles in 4 hours. Another way I could say that is 224 miles per 4 hours. That is not your seat, Mason. All right, now, the question is asking how long. What do they mean when they're asking how long? It's a weird English word phrase that doesn't make any sense, especially if this is your second language, because long implies length, right? What do they mean? What are they asking us to figure out when they say how long would it take him to drive? The time, yes. When they say how long, we're actually asking us to find the time it would take him to drive 490 miles. So I have another fraction on this other side. We know the 490 miles. Where should I put the 490 miles in my fraction here? On the top. Why do we put the 490 miles on the top? So it's consistent. Yeah, we've got miles on the numerators, okay? Now, they want us to figure out how long. Do we know how long it's going to take? No, that's what we're trying to figure out. So that's our variable. And do we want to use t for time? Yeah, okay. So t hours is what we're trying to figure out, okay? So now you can see my units match on the top and my units match on the bottom. It's nice and consistent. And so now we can go ahead and solve. How do we solve a proportion? Cross multiply, yeah, cross multiply. So we are going to multiply 4 times 490, and that's going to be equal to what times what? Yeah, t times 224. Ladies and gentlemen, what is 4 times 490? 1,960. Very good. Equals 224t. How do we get t by itself? Divide by 224 on both sides. And so we get t equals, what is 1960 divided by 224? 8.75. All right. Should I just use 8.75? Yeah, it's a terminating decimal, so that's pretty good. When we talked about t, what does 8.75 mean? What units are on the 8.75? Hours. Very good. And we wrote it right up here to help us out. So 8.75 hours. So it took him 8.75 hours, which would be 8 hours and 45 minutes. Very good. 8 hours and 45 minutes to drive that 490 miles. Okay. Number 2. Approximately 4 out of 5. 4 out of 5. Ladies and gentlemen, when you read that, do you see a fraction? Yeah, good. I'm so glad. 4 out of 5 is a fraction. It's a great fraction. 4 out of 5 students in Mrs. Hayes' 7th grade math class have cell phones. What does that mean? 4 out of 5 have cell phones. Yeah, so what does the 4 represent? The number of cell phones, yeah, cell phones. All right, and then 5 is the total number of people she asked, right? The number of people. All right, 4 have a cell phone, but there's 5 people that we asked, okay? Now, in Mrs. Hayes' 7th grade math class, if there are 365 students in the 7th grade, how many would you expect to have a cell phone? Okay, that's another fraction. Now the question is, where do we put that information? Where does the 365 students go? On the bottom, yeah, that 365. Those are the people that we have, the total number of people that we're talking about. I could change that word to students, total students, okay? How many would you expect to have a cell phone? What should we do for that? C, yeah, sure, we could use a C. That's what we're trying to figure out, where C is the number of cell phones that we're looking for. So again, we've got the number of cell phones units on top, and then the people or the total students on the bottom. So that's our great setup, and from there we can do what to solve? Cross multiply. Very good. So we're going to multiply 5 times C, and Easton, we're going to multiply
4 and 365.
4 times 365. All right, so we have 5 C's equals, what is 4 times 365? 1460. And then how do we get C by itself? Divide by 5, divide by 5. Blake, you writing this down?
I already has it all done.
Oh. What is 1460 divided by 5? 292. And what did that represent? C, cell phones. So 292 students have cell phones. All right. All right. Do you have questions on this so far?
No.
No? Is it pretty easy? It's not too bad. I think they're pretty good. Okay, let's look at number 4. It takes 1 1/4 cups of milk to make 8 pancakes. Ladies and gentlemen, when you read that, do you see a fraction? Yeah? What is our fraction we're going to write? 1 1/4. I really hate that. Is there something else I could do instead of writing a mixed number? 5 over 4. We could absolutely do 5 over 4. Is there something else I could do? 1.25. 1.25. Yes, ladies and gentlemen. 1 1/4 is 1.25, which, of course, if we knew 5 over 4, I can just use the decimal. Oops, there you go. 1.25. Okay, I would much rather use that in a problem like this. So, what's my fraction going to be? 1.25 over 8. Okay, what are the units on those numbers? What does 1.25 represent? Milk. Okay, so cups of milk. Cups of milk. And what does the 8 represent? Pancakes. All right. All right, so there's my fraction, 1.25 cups of milk over 8 pancakes. All right. Now, then it's asking how many cups of milk are needed to make 20 pancakes? So now, what goes where, ladies and gentlemen? Where does the 20 go? 20 goes on the bottom. 20 goes on the bottom because it was 20 pancakes. And so what are we trying to figure out? The milk. What can we use to represent our cups of milk? M, okay, so M cups of milk. All right, that'll work. Could we use any letter we want? Could we use X? Yeah. Could we use C? Yeah, okay, good. All right, and then how do we solve this lovely proportion? Cross multiply. Will you go ahead and finish this up, please? Use your calculator. Do. Okay. What did you get for your M? 3.125. 3.125 was cups of milk. All right. 3.125 cups of milk. All right. Do you have any questions on this one?
3 and 1/8.
It is 3 and 1/8. Very good. It is 3 and 1/8. Very good. All right. Turn the page. No. They get a little more challenging. All right, number 5. Melanie can run around the track 9 times in 28 minutes. Ladies and gentlemen, what fraction do you read just now? 9 over 28. And what are the units of that? Laps. Sure. Laps per minute. Very good. Laps per minute. 9 times. 9 laps in 28 minutes. At this rate, how many laps can she run in 1 hour and 15 minutes? What do we need to do here to finish our little proportion?
Convert the 1 hour.
Yeah, can we use 1 hour and 15 minutes? That's a little too complicated. 75? Okay. 1 hour is 60 minutes plus the 15 minutes, so that is 75 minutes. When we set up our proportion, we started with minutes, which means we have to use minutes. So 75 minutes. Now, what should go on top? Laps. We're trying to figure out how many laps. So I'm going to use an L for that. So L laps. All right, ladies and gentlemen, go ahead and solve that out for me, please. Cross multiply to solve. Bless you. I see lots of people using those calculators, writing stuff down. Good for you. Thank you. All right, what did you get for L? 24.1 laps. Very good. 24.1 laps. Fantastic. Okay. Any questions on that one? No. All right, number 8. Jack bought 3 binders from the store and paid $13.17. If he goes back to the store to purchase 5 more binders, how much in total will he have spent on the binders? He bought 3 binders from the store and paid $13.17. Are you seeing a fraction there? Is there only one way to do a problem? No. There's more than one way to do a problem, isn't there? Okay. So there is more than one way. The objective of this worksheet is to use proportions. And this problem, actually, we could solve another way pretty easily. You already did. Did you use a proportion, or did you just figured out?
I did 13.17 divided by 3.
And what does that give you?
439.
And that 439?
It by 5 and got that answer, and then I added 13.17.
Okay. So there are many ways to do problems. So my question to you is, do you want to use a proportion to solve this? All right. So if we spent a total of $13.17 on 3 binders, I can figure out the cost per binder, can't I? Okay. So what is 13.17 divided by 3? $4.39 per binder. All right. So we can figure out the unit price, the price per single unit. Now he goes back to the store to purchase 5 more binders. Well, can I figure out how much that's going to cost him? Yeah, what can I do? Yeah, $4.39 times 5 binders, okay, and that will give me $21.95. All right, so he went and he got 5 more binders. He spent $21.98 this time. So then the question is really asking how much in total will he have spent? 95, thank you. How do we figure out how much in total he spent? Add them. Add what? Yeah, the total he spent would be $13.17 plus the $21.95 on the second trip. So $13.17 plus $21.95 for a total of $35.12. So it is kind of interesting. I don't care, ladies and gentlemen. This one, absolutely, there's more than one way to solve them, but proportions work as well. Let's see. Let's look at number 10. Emily typed 456 words in 8 minutes. Do you see a fraction in that? What's your fraction? 456 over 8. Yeah, 456 words in 8 minutes. 456 words in 8 minutes. Her friend Mary typed, interesting, 32 fewer words in the same time frame. What does that mean? Yeah, so is this fraction representing Emily or is it representing Mary? Yeah, this is Emily's fraction. Let's keep reading because now I'm confused. At the same rate, how long would it take Mary to type 954 words? Okay, do I care about Emily's little rate here? No, that's actually not helpful to me. I need to care about Mary. Let's see, it says Mary typed 32 fewer words in the same time. Emily was 456. So how many words did Mary type? How'd you get that? You subtracted, yeah. 456 minus 32, we get 424 words. All right, so Mary typed a little bit slower. What's on the bottom? As the same time frame, it also took her 8 minutes, and she did 424 words. Okay, so this is Mary's words per minute. At that same rate, how long would it take Mary to type 954 words? So where does the 954 go? On the top, 954 words. What should we put on the bottom? M for Mary, sure. At the same, how long would it take Mary? That would be M minutes. Mary's minutes. Okay, and from here we can cross multiply. So many of these questions you really need to read carefully, right? All right. So we're going to cross multiply to solve here. So we have 8 times 954 is equal to M times 424. Let's see, 8 times 954 is 7632. 424 M. How do we get M by itself? Divide by 424. Divide by 424. Divide by 424. All right, so 7632 divided by 424 is 18. So it took Mary 18 minutes. 18 minutes. All right, let's look at number 12. Can you be done? Again, many ways, yeah? Oh, again, 12, I think, 12 you could find a different way too. Let's look at number 11, rather, instead of number 12, sorry. Carrie sent a total of 190 text messages in the first 5 days of May. Do you see a fraction there? 190 over 5 days. 190 texts over 5 days. If the text messages cost 4 cents each, how much should she expect to pay that month? What month are we talking about? May. How many days? How many days are in May? 31. 30 days has September, April, June, and November. All the rest has 31. So 31. 31 days. So we need to figure out how many texts that she's going to get in May. So X texts. All right, I'm going to go ahead and cross multiply here. We have 5 times X equals 31 times 190. That'll give us how many texts that's a lot of texts. 31 times 190. Wow. Jesus. 5,890 texts. Okay, divided by 5. Because I got to get X by itself. All right, so she sent 1,178 texts in the month of May. She sent 1,000. Do you send that many text messages? Do you respond on like Snapchat or Insta that much? Like that seems like a lot, doesn't it? It's like crazy. Okay. All right. That's crazy. All right. Yeah. Okay. So she sent 1,178 texts. How much should she expect to pay? That's what we have to figure out. What do we need to do to figure out that she's expected to pay? Divided? Times. So 1,178 texts, it costs 4 cents each. $47. Oh, okay. So what did you multiply by? Did you multiply by 4?
Then divided by 100.
Oh, okay. So 4 cents, I'm going to multiply it by its decimal, which is 0.04. That's 4 cents. All right. And then, so Easton multiplied by 4 and then divided by 100, which will give us the same result. All right, we get $47.12 for what she ends up paying for those text messages. Could you imagine? Once upon a time, we had to pay for text messages per instance. So, yeah, early on, you had to pay extra for that.
It might not be that bad. Like, how it's already into your plan or something right now?
Yeah.
Just like